Hey everyone, welcome to The Explainer. Today, we're looking at some research that honestly feels like it was ripped straight out of a science fiction novel. Okay, let's just dive right into this. We're exploring a truly groundbreaking paper titled Infinite Worlds with Versatile Interactions, and it was put together by a massive team of 20 researchers led by Zilin Gao. If you're at all fascinated by the bleeding edge of AI, world simulation, or, the future of gaming, you are definitely going to want to pay close attention to this one. We're going to unpack exactly how this team is pushing the boundaries of what AI can generate in real time.
So what if a video game world was truly infinite? I mean, imagine the absolute holy grail of interactive media for a second. We're not talking about procedural generation here, where a computer just snaps together pre-made Lego blocks of terrain. No, we're talking about a completely limitless, reactive virtual reality that is generated on the fly by artificial intelligence. A world where you can go anywhere, do anything, and the environment just dynamically invents itself as you play, constantly reacting to your choices without ever breaking the illusion. It sounds like something that's maybe 50 years away, right? But as the researchers of our source paper point out, that future is actually arriving right now.
Section 1. Upgrading to Infinity. The engine turning this whole sci-fi dream into a tangible reality is a system the authors call LingBot World 2.0, also fittingly referred to as LingBot World Infinity. Now, it introduces some massive upgrades to solve one of the biggest headaches in generative AI, which is hallucination. If you've ever messed around with AI video or text generation, you know that over time, the AI tends to just forget what happened a few moments ago. A red car suddenly turns blue, or a door you just walked through completely vanishes. To fix this, the team introduced a causal pre-training paradigm. Basically, that's a highly technical way of saying they figured out a training method that gives the AI an unbounded interaction horizon. It actually remembers the past. It maintains consistent output over long periods. You can turn around in this generated world, and the mountain you were just looking at, it's still right there, exactly as you left it. The world doesn't just break down into a messy soup the longer you play. Now, consistency is amazing, but it really means nothing if it takes 10 minutes to render a single frame. And that brings us to the second upgrade, represented by a very important number, 60. The research team successfully distilled a real-time variant from their massive base model, and this distilled system guarantees a rapid response time that runs at a blistering 60 frames per second. In the gaming world, 60 FPS is basically the gold standard for smooth, responsive gameplay. Achieving this with a world that is literally being generated into existence by AI on the fly, it's nothing short of a monumental engineering feat. And here's the kicker. This incredible speed doesn't compromise the visual fidelity. The system is simultaneously pushing 720p video streams. It's crossing a critical threshold here. We aren't looking at blurry, low-resolution, postage stamp-sized experimental videos anymore. We're looking at high-definition, fluid, real-time video streams capable of supporting really smooth human interaction. It's fast enough and sharp enough to actually sit down and just play. Section 2. Real-time action and spells. So we have an infinite, consistent, high-def world running at 60 frames per second. But a world is just a pretty screensaver unless you can actually do something inside of it, right? Well, the third major upgrade completely overhauled what players can achieve inside the simulation. The researchers didn't just build a basic walking simulator. They built a system capable of handling highly diverse interactive elements. As a player, you can engage in attacking, archery, spellcasting, shooting, and a huge variety of text-driven events. You're not just bumping into walls, you're firing arrows, you're casting spells, and you're watching the AI seamlessly generate the visual and physical consequences of those actions in real time. The AI is operating way less like a simple physics simulator and much more like a fully fledged, dynamic RPG engine. Section 3. The Pilot and Director. But you might be wondering, how exactly does the AI manage to juggle your inputs, generate the environment, and keep the gameplay compelling all at the exact same time? To solve this, the team pioneered the integration of something called an agentic harness within the domain of world modeling. The way this functions is super interesting. It relies on a multi-agent system, elegantly split into two distinct roles. On one side, we have the pilot agent. Think of the pilot as the actor on a stage. It's tasked with planning and executing character behaviors based on your input. On the flip side, we have the director agent. Just like a movie director, this agent sits behind the camera, responsible for synthesizing novel environmental elements on the fly as the scene progresses. So while you interact through the pilot, the director is constantly working in the background, building the stage, placing the props, and ensuring the world around you is constantly evolving and staying interesting. They work in tandem, literally building and playing the world simultaneously. And beyond the single-player experience, this isn't just a solitary engine. The research team specifically developed an interface to facilitate a shared experience. Multiple players can simultaneously immerse themselves in this vivid world simulator. You and your friends can exist in the exact same AI-generated infinite space, casting spells and exploring environments that the director agent is conjuring up around all of you in real time. It's a true multiplayer environment built entirely on neural networks, which is absolutely wild.
Section 4. Bringing the world home. Now, hearing about massive, infinite AI models usually comes with a huge catch, right? You typically need a multi-million-dollar supercomputer just to turn the thing on. But one of the most vital aspects of this paper is the researchers' focus on deployment and accessibility. They paired their primary massive 14 billion parameter model, which, naturally requires a high-end setup to run at full fidelity, with a lightweight 1.3 billion parameter counterpart. And this lightweight model supports effortless deployment on just a single GPU. You don't need a server farm. A standard, reasonably powered local graphics card is completely enough to tap into this technology and start exploring these versatile interactions for yourself. So we've gone from the conceptual dream of an infinite game world all the way down to a 1.3 billion parameter model that you can run on a single GPU. LingBot World Infinity represents a truly massive leap forward. With its causal pre-training for long-term memory, its 60 FPS real-time generation, its deep RPG-style interactions, and that awesome dual-pilot director setup, the foundation for the future of interactive media has literally been laid. So I'll leave you with this final question to ponder. What will you build in an infinite shared AI world? The tools are arriving and the boundaries are disappearing. I highly encourage you to seek out the source paper by Zilin Gao and the rest of the team to dive deeper into the incredible engineering that makes all this possible. Thank you so much for joining me for this explainer, and keep exploring.